Okay, what do you think about problem F, 2F?
You can't do it.
You can't do it. Very good. I hope, guys, that even if you tried to do it, I hope you discovered you couldn't, because the numbers don't all have matches. The dimensions aren't right. You cannot multiply a 2 by 2 times a 3 by 3. It is impossible. Everybody okay with that? So you just say can't do and move on. Now, G. This capital T, or it doesn't even always have to be a capital, the superscript, the T written up above like an exponent position, that indicates transpose. And the transpose of a matrix simply switches its rows and columns. So what I mean by that is, you have matrix A on your paper. I'll write it up here. 1, maybe 2, 3, 5. The transpose says whatever was row 1 becomes column 1. So row 1 becomes column 1 when you do the transpose. The transpose switches the rows and columns. So then row 2 becomes column 2. Now notice that row 1 is now 1, 3, and that used to be column 1. That's how it works. What was a row becomes a column, and vice versa. So that's a transpose, and we're supposed to multiply that times B. Now, can we even do that? Is this a multipliable situation? Yes. I see some nods. I wish you guys would speak up. You're just these little tiny faces on here. I need to hear you. So yes, it's possible, and our answer will be another 2 by 2. All right? This one you can multiply. So let's go ahead and have you practice row 1, column 1, and so on, and see if you can fill those in. And I'll do it too, and I'll see what I get. We'll see if we match. If you think you have the numbers, shout them out. We'll check. Oh, you guys. Ellie, what'd you get right here? Ellie, you got this one done?
I got 6.
I did too. Perfect. We're going to assume that's right. Gabe, Tice, you got this one?
Yeah, I got -1.
Okay, I didn't, but that doesn't mean anything. So let's double check. So that spot would be row 1, column 2. Row
Just
1.
did the math wrong.
Maybe. It's easy to do. So row 1 is 1, 3. And column 2 is 3, -4. So I got 3 minus 12. I got -9. Can you figure out what you did wrong, Gabe, so you don't do it again?
Yeah.
Did you find it?
Yeah.
Okay, good. Good, good, good. All right, Sam Tuttle, you got this spot figured out?
Not yet.
Okay, well, do it as quick as you can. And then Drake, how about this one? Drake, you got this last
I got
one
negative 15.
for here? I did not.
Negative 15.
Okay, let's check and see. We're doing Drake's. Drake's is right here. That second row, second column. So that'll be negative 2, 5, and 3, negative 4. So Drake, I got negative 6 and negative 20. I got negative 26.
Yeah, I know what I did wrong.
Okay, good. Good, good, good. Sam, you got this one figured out now? Can't hear you, Sam. Who can help Sam? He's muted.
My fault. I didn't know I was muted. I said I'm sorry. I still haven't figured.
Okay, I need you to pay attention, Sam. All right? I need you to pay close attention. So whatever you got going on that screen that you're looking at, or whatever that is you're looking at there, I want you to stop it and I want you to focus. To find this position, that
Is it negative 12?
it is negative 12. At least that's what I got. It's negative 2, 5 times 6, 0, and that would be negative 12. Perfect. All right. Now, H is asking you to evaluate the determinant. So that DET stands for the determinant of A. So that's DETA. And it is also written, its notation is the vertical bars that look kind of like absolute value. The vertical bars. So these are the numbers in matrix A. I copied it exactly, but instead of using the brackets, I use the vertical bars because this is a determinant problem, and that is the notation for a determinant. Now, the determinant of a matrix is a single number. And to find that number for a 2 by 2, like this one is a 2 by 2, we multiply these together. Look where I'm pointing. We always start here. We multiply these together, so we get 5. And then we multiply these together, so we get negative 6. Everybody with me so far? I got 5 on this diagonal, negative 6 on this diagonal, and it's always that order because now I'm going to subtract them. So I got to do it in the right order or I'll get the wrong answer. So it's 5 minus negative 6. So the value of that determinant is simply 11. Now the next one's going to be the same thing. What will the value of this determinant be? Remember, you multiply, and subtract. So it's going to be negative 24 minus 0. So that determinant is negative 24. Now, right now, you're wondering, what the heck do we have determinants for? Well, they're used for many, many things. And we're going to discover some of them here later today and in the coming days. But you have to know how to evaluate them. Determinants only exist for square matrices. You cannot find a determinant if the matrix isn't square. So if you notice, J, problem J, says find the determinant of C. Well, I should be able to do that because C is square. It's a 3 by 3. Well, how does it work? Well, it sort of works the same way. It just is a little bit bigger. So here's what you do. We're going to find the determinant of C. Remember, in matrix land, those vertical bars always mean determinant. Always mean determinant. And that means the answer is going to be a number, a single number. All right, so for one this size, 3 by 3, what we do is we take the first two columns, remember columns go up and down, these are the columns, and we simply write them outside the determinant. So there's the first one, 1, 0, 1, and here's the second one, negative 1, 3, 4. Make sure you're doing them in order, so I just cut them out, paste them here, and if there's negatives, make sure you're bringing those along too. Okay? Now, always start right here. Start at the beginning. This is the first number in the matrix or in the determinant. Start here. Multiply these together. I got 0. Now, multiply these together. I got 1. And then multiply these together. And I got another 0. So we have 3 multiplications to do. 0, 1, 0. Total those up. So that's a 1. Now do the same thing in the other direction. So multiply these together. I got 6. Multiply these together. I got negative 4. And multiply these together. I got 0. Now total those up. I got 2. Now, do you remember when we did the little ones? You multiplied these, you started here, you multiplied these and got 4, and then you multiplied these and got 6. So this multiplication was a 4, this multiplication was a 6, and then what did you do to those two numbers?
Add them.
Oh, subtract, 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 subtract. So it's downs minus ups, okay? So 4 minus 6. This one is the same way. The downs totaled 1, the ups totaled 2, so your answer is 1 minus 2, or negative 1. So the concept is the same, downs minus ups. But with a little one, you only have 1 multiplication each way. For the bigger ones, you have 3 multiplications, and that totals your downs, and then 3 more multiplications, and that totals your ups. But you still subtract downs minus ups. Downs, right here, start here, down. Anybody have a question about where one of those numbers came from? Okay, we're going to practice another one in a second. Look at problem K. Problem K is not doable. Problem K is no answer. Impossible. Can't do. Why is that? What did I just tell you about finding determinants? They gotta be square. Is D square? help me out. I'm talking to myself. D is not square because what are its dimensions?
2 by
2 to
3.
2 by 3. If it's not square, you can't do the determinant. It's not possible. Move on. Number 3 is possible. Number 3 says, find the determinant for this matrix. This is what we just did. It's a 3 by 3, and we're going to find its determinant. Now, I know that you've only done one of these, but can anybody remember how we get started? What do we have to do to get started?
Take the first
Don't you take the first 2 columns and put them on the outside?
I do. So I'm going to take my first 2 columns, 3, 6, -1, and 0, 1, 5. Please don't switch anything. Just cut them out and paste them on to the end of the determinant. Now we're going to do some multiplying, and we always start with the very first number. Start right here. And we multiply down. So this multiplication would give me -6. This one would give me 0. Oh boy, and this one is going to give me 150. And then add them up. That's your total for the downs. So what is that, 144? Now do the same thing with your ups. So -5. Oh, these numbers are big. 45 and 0. So that's a 40. Now, what do I do with these 2 numbers?
144 minus 40.
I subtract them, exactly. Downs minus ups. So my answer is 104. That's the final answer to the problem. Guys, if you need more practice, remember I always put supplemental homework from your textbook into Schoology. So if you want to practice some more of these, you can. You've got to be able to do this. You have to be able to do that process. All right, we're going to do a few more here before we break for lunch, and I won't see you anymore then today. So A inverse, I'm going to find A inverse. This means the inverse of A. I'm going to find the inverse of A. You remember that notation. That's your inverse notation. And A is 1, -2, 3, 5. Now, finding the inverse, again, very simple, but there's a process to it that you have to remember. And for the inverse, it's actually a 2-step process. The first step is find the determinant. Okay, so we're going to find the determinant of this matrix. Now, catch your breath. I've given you a lot of information today. Think about this. Remember, determinant is down minus up. So we're going to multiply, and then subtract. So are you good with the determinant being 11?
Why isn't it -11?
Because it's down is 5, and up is -6, and we always subtract down minus up, so it's 5 minus -6. That's positive 11. You've got to remember that you start here. This is the beginning. So it's this minus this. 5 minus negative 6. So, step 1 to finding the inverse is find the determinant. Now, step 2, we're going to build a new matrix called the adjoint. This is going to be a new matrix associated with that one. It's called the adjoint. Now, it's really simple with a 2 by 2. It gets a little more complicated when they get bigger, but we're going to do the bigger ones on our calculator, so we don't have to worry about the complications. This is pretty easy. To build this new matrix, it's going to be the same size as the original. Look where my fingers are. Those two numbers where my fingers are, switch. So 5 goes here and 1 goes here. When you do the adjoint, you take these two numbers and switch them. Now the other two numbers stay where they are, but you make them the opposite. So what I mean is, instead of negative 2, this is going to be a positive 2. And instead of positive 3, this is going to be a negative 3. So these two numbers switch places, physically switch, and these two become the opposite. So a negative 2 becomes a positive 2, a positive 3 becomes a negative 3. Now I'm not switching these, I'm not like switching these two signs back and forth. If this had been a negative 3, that would be a positive 3. You make them the opposite of whatever they are. And then your answer, those are the two steps, those are the two pieces. And to get the answer then, you simply take the adjoint matrix and divide each piece of it by the determinant. So your your inverse is 5/11, 2/11, negative 3/11, and 1/11. All right, let's try the next one. Now we're going to find the inverse of matrix B, and then I'm going to show you what an inverse means, and then we're going to be done for today. All right, so we got to do B inverse. So what was matrix B? 6, 3, 0, negative 4. All right, so the first thing I'm going to do is find the determinant. So go ahead. Find the determinant. Did you get negative 24 for your determinant? Negative 24 minus 0. All right, let's build our adjoint then. Remember where my fingers are, flip-flop. So this is going to be negative 4 and 6. Now 0 just stays 0. You can't really change its sign. But that 3 becomes negative. All right. Now, we've got both pieces of the puzzle, so now we're going to divide everything by negative 24. And then we're going to simplify our answer. So B inverse will be 1/6, 1/8, 0, and negative 1/4. Are we good with that, guys? All right, let me show you what it means to be an inverse then, and then we'll be finished. So here's what I'd like you to do. I'd like you to, over to the side somewhere, I don't know, in the margin, up the side or something, I want you to multiply matrix B times the inverse that you just got. Alrighty, so what I'm going to do is take my original matrix B and I'm going to multiply it by this new matrix, this inverse thing that I built. Now, first of all, that's going to be possible, and the answer is going to be another 2 by 2. But the answer is the interesting part. What is this answer going to look like? Well, let's take our first row times our first column. So first row, 6, 3. First column, 1, 6, 0. Isn't that just 1? All right, now let's take our first row, our 6, 3, times our second column, 1/8, negative 1/4. Now the fractions are just a fact of life with inverses. It's a little bit annoying, but isn't 6 times 1/8, isn't that 3/4? 6/8? Remember? 6 over 1, 1 over 8, 6/8 minus 3/4. So that one's a 0. All right. Let's try second row, first column. Well, that's just 0. And then second row, second column, and that's just 1. That matrix right there is called the identity matrix. And basically what happens when you multiply inverses is they cancel each other out. It's the same thing that happens in regular arithmetic. It's the same thing that happens in the composition of functions. They cancel each other out and they will give you the identity. If these had been 3 by 3s, that identity looks like this. So in other words, it's all zeros except for the main diagonal, and that is all 1s. So that's the identity matrix for a 3 by 3. That's the identity for a 2 by 2. Remember that in order to find an inverse, you have to find the determinant first. But in order to find a determinant, the matrix has to be square. So the only way you can have an inverse is if you're square. So hang on to that thought. I think I have to let you go eat now. So I shall, unfortunately, makes me sad, but you have to eat. So I will see you tomorrow or the next day. Have a wonderful day. Thank you for stopping by.
Thank you.
Bye-bye.
Thank you.
You're
Thank you.
welcome. See you later.